Mastering smart manufacturing. Simplify or die/waste, variability, and complexity to reign supreme in smart manufacturing. Where can we identify opportunities to simplify and streamline our operational processes to minimize waste, variability, and unnecessary complexity, thereby achieving greater operational excellence and efficiency in our smart manufacturing environment? Identifying opportunities to simplify and streamline operational processes is crucial in achieving greater operational excellence and efficiency in a smart manufacturing environment. This can be achieved by implementing a combination of strategic initiatives, technological advancements, and cultural transformations. Firstly, a thorough mapping of the current value stream and identification of pain points is necessary. This can be achieved through the application of tools such as swim lane analysis, process mapping, and root cause analysis. These tools enable the visualization of complex processes, identification of inefficiencies, and pinpointing of areas that require improvement. This exercise will help identify waste, variability, and unnecessary complexity in the operational processes. Secondly, the implementation of lean principles and total productive maintenance, TPM, can help minimize waste, reduce variability, and eliminate unnecessary complexity. Lean principles focus on creating value for the customer by eliminating non-value-added activities, reducing waste, and maximizing flow. TPM, on the other hand, is a maintenance strategy that aims to maximize equipment effectiveness by reducing downtime, improving quality, and reducing costs. Thirdly, the adoption of Industry 4.0 technologies such as IoT, AI, and data analytics can help streamline operational processes. IoT sensors can be used to monitor equipment performance, detect anomalies, and predict maintenance requirements. AI-powered algorithms can analyze data from various sources to identify patterns, trends, and correlations, enabling proactive decision-making. Data analytics can provide real-time insights into operational performance, enabling swift response to changes in demand, supply chain disruptions, or quality issues. Fourthly, the implementation of automation and robotics can help minimize waste, reduce variability, and eliminate unnecessary complexity. Automation can improve product quality, reduce manual errors, and increase production efficiency. Robotics can assist in tasks such as material handling, inspection, and packaging, freeing up human resources for higher value tasks. Fifthly, the development of a culture of continuous improvement and empowerment is essential. This can be achieved by providing training and development opportunities, empowering employees to identify and solve problems, and recognizing and rewarding innovative ideas. A culture of continuous improvement encourages experimentation, learning from failures, and collaboration across departments. Sixthly, the implementation of performance metrics and key performance indicators, KPIs, is crucial in measuring operational excellence and efficiency. Metrics such as overall equipment effectiveness, OEE, mean time between failures, MTBF, and mean time to repair, MTTR, provide insights into equipment performance, while metrics such as lead time, throughput, and quality rate provide insights into process efficiency. Seventhly, the establishment of a centralized data repository and the implementation of digital twin technology can help streamline operational processes. A centralized data repository enables the integration of data from various sources, providing a single source of truth for operational data. Digital twin technology enables the creation of virtual replicas of physical assets, allowing for simulation, testing, and optimization of operational processes. Lastly, the development of strategic partnerships and collaborations with suppliers, customers, and research institutions can help access new technologies, share best practices, and leverage expertise. This can lead to the development of new products, services, and business models that can drive growth and competitiveness. In conclusion, achieving operational excellence and efficiency in a smart manufacturing environment requires a multifaceted approach that incorporates strategic initiatives, technological advancements, cultural transformations, and performance metrics. By implementing these solutions, manufacturers can minimize waste, variability, and unnecessary complexity, and achieve greater operational excellence and efficiency.